Guys, Mr. Sonnenberg here. Today we're going to be talking about the cost of lighting. So this is for Science 8 students studying Light and Optical Systems, topic 1 in your textbook. And basically what we're going to look at is how do we determine the cost of lighting. If we leave lights on, how much extra cost or what's the cost going to be to us as the potential homeowner or owner of a business and such. So you always hear people saying, turn the lights off, turn the lights off. One, we're consuming less natural resources when we do it, but also the second is it costs money to have lights on and to utilize electricity throughout the household. So how can we take that and limit the cost to us by also being more environmentally friendly at the same time? So cost of lighting, okay? So electrical energy, it costs money to produce, like I just said. So uh, we uh, we measure our electrical power by a unit that we call a watt, and that's right there. Now a watt will be symbolized in chemical formula as a W, a large W, okay? And then if we wanted to look at what would be, I'll just put it down here, a kilowatt, okay, so a kilowatt's going to be a lowercase k and an uppercase W. So that's a kilowatt. And we'll talk about the conversions of watts and kilowatts in a second. So again, I would like to remind you that you should be writing down notes as we go through this as well. If you need to pause the video to jot something down, you have the ability to do that as well. So the cost is calculated basically by how much electrical energy we're consuming or using over what period of time we use it. So an example is if I'm operating, I'm using 1 kilowatt an hour, well that means I'm going to be using 1 kilowatt. Okay, so I'm using 1 kilowatt. That's an uppercase K, sorry, my bad. A kilowatt per 1 hour. Okay. Now, if you look here, it says 1 kilowatt is also 1,000 watts. So that's our conversion. 1 kilowatt. Okay, so 1 kilowatt is equal to 1,000 watts. Okay. So you might see these conversions, which is really important to pay attention to when you're trying to calculate the cost of lighting and you're going through the formulas and such, because those conversions become very important. So what we're saying is over what amount of electrical energy is being used over what period of time. What's the time duration? How many hours? How many minutes? How many seconds? Versus how many kilowatts, or if we were to convert it to watts, times it by 1,000, how many watts? Okay. So let's just look at an example here on the next page. So cost of lighting, an example. We want to calculate the cost of leaving a 60-watt light bulb on for 10 hours. So a few of the steps that we have to go through in order to do this. Well, step one, we need to look at a conversion. So if I say I need to convert 60 watts because I need to get it in kilowatts to kilowatts here, well, I'm going to divide it by, okay, so I'm going to divide it by 1,000. So now I'm going to actually show me doing that over here. So sometimes this symbol right here, okay, that's also going to mean divide. So if you see that symbol, it means divide. Okay, so 60 watts divided by 1,000 is going to leave me with 0.06 kilowatts. Okay, I've divided by 1,000. I've converted my 60 watts from my equation into my kilowatts. Now step two, I'm going to calculate the number of kilowatts per hour. Well, how many hours? Well, we look up here. It said the bulb was on for 10 hours. Okay, so now I have the duration of time. Alright, well now I have to take my kilowatt number, which is found right here, and I have to multiply it by the number of hours, which was 10. So that you can actually see this happening right here. So 0.06 kilowatts times 10 hours is going to be 0.6 kilowatts per hour. Now notice I always include the value at the end, so the numerical value, but then I also talk about what those values are. So I've multiplied kilowatts and hours, and I get kilowatt hours. Now I go into the third and final step. I want to calculate the cost by multiplying the number of hours. Okay, so by the cost per week. So if I want to go one step farther, I can say, okay, well, if the cost per week or per kilowatt hour is 0.8 cent or dollars, so also known as 8 cents, I'll just do this, 8 cents, okay, the cost of electricity to operate the 60-watt light bulb for 2 hours would be, well, now what I need to do is I need to look at the cents value. I look at how many kilowatts per hour, okay, and then I need to multiply it by however many cents it costs to operate that light bulb, okay, and I get 4.8 cents or about 5 cents. Okay, so that's just one form, and I'm actually going to run through an example to show you how it would work. But these are, one, we need to understand the conversion and be able to convert watts to kilowatts. Second is we should be able to multiply it by the amount of hours. And then the last is now we have to incorporate, well, what's the cost? So sure, I have 0.6 kilowatts per hour, but then how many cents is it going to cost me? How do I determine an actual amount that it's going to cost me for leaving this light bulb on? And now if I was to do that over 365 days, what's the additional cost? And then I look at, one, how have I affected the environment, and two, what could I have bought with those additional funds I just threw away by leaving my lights on. Plus cost of replacing light bulbs as well becomes a little expensive. So let's look at this example and just wrap this up. So it says assume that electricity costs 8 cents per kilowatt hour, just as we showed in the last example. This means if a 1,000-watt appliance is left on for 1 hour, it uses 8 cents worth of electricity. So I just showing the formula right here that we'll be using. So cost equals the number of kilowatts times the number of hours times 8 cents. So the number, we have to convert that even further, because remember we have to convert kilowatts or watts into kilowatts. And since this equation or this word problem gives us 1,000 watts, we need to convert it into kilowatts. Okay, so we do that by dividing by 1,000. Then we're going to multiply it by a number of hours, okay, which is 1 hour in this case, and then times 8 cents. So now let's just take a look at this equation here. Or this question. It says, what is the cost of electricity in the following situation? It says 100-watt light bulb. Well, right away I look at what I have. So I have my electrical power. Okay, my electrical power is going to equal 100 watts, but I have to convert that into kilowatts. So I'm going to go 100 watts divided by 1,000. Okay, and that's going to leave me with the specific amount of watts that I need. Okay, so what's one easy way to do that? Well, I can go back 1, 2, 3 places, right, with my decimal. Okay, so now it's going to equal 0.1 kilowatts. Okay, now what else do I know? Well, the light bulb was left on. Well, I know the cost. I know the cost is equals 8 cents. Okay, so, and that's 8 cents per kilowatt hour. Now, I also know that I know the duration of time, and that was important. So it's from 10 at night to 7 in the morning. So if we go from 10, so we go to 11, 12, 1, 2, 3, 4, 5, 6, 7. So it's been left on for 9 hours. So how many hours was it? It was left on for 9 hours. Okay, so now I know the information, but now I want to know what was the cost of electricity. Well, my cost is going to equal, and remember from up here, okay, my cost is going to equal, I'm just going to fill this in. It's going to equal 0.1 kilowatts, okay, then it's going to be multiplied by the number of hours, okay, which was 9 hours, Okay, and then it's also going to be multiplied by cents. Oops. By the cents per kilowatt hour, so which is going to be 8 cents per kilowatt hour. Okay, so then what's that going to equal? So I multiply that all together and I end up getting 7.2 cents. So how much did it cost for me to leave a 100-watt light bulb on from 10 a.m. to 10 p.m. to 7 a.m. the next morning? So what was the cost of electricity? Well, it cost me an additional 7.2 cents, and that's just one 100-watt light bulb. So this is how we find. First, I've established what I know right here. Okay, I had to do a little figuring out of the hours by calculating the hours based on the time at night to the time in the morning. I had to convert my 100-watt light bulb into kilowatts by dividing by 1,000, and then I had to plug everything into this formula up top here, okay, to ensure that I could do the proper calculations. And I determined that it costs 7.2 cents to leave a 100-watt light bulb on for 9 hours if the cost is 8 cents per kilowatt hour. So hopefully this helps you guys out. That is how to determine cost of lighting. Again, we look at this and we've talked about light sources, what is light, and I have to understand that light is a form of energy, but it comes with a cost. So next time we're leaving a light bulb on, maybe we should think about turning it off, because 7.2 cents at a time might add up in a hurry if we're leaving several light bulbs on. Anyways, hope this has helped. Thanks for tuning in, guys, and we'll see you on the next screencast.